All right, welcome back, guys. This is Mr. Lowry. Today in class, which was Thursday, we started this in-class activity called Strategies for Solving Equations with Fractions. We didn't get all the way through it, so we'll continue it on Friday as well. But I want to get you started for those of you who maybe needed a little extra help or who were absent for this day. This will help you get started, okay? So what we did in class is I gave everybody a few minutes to work on problems 1 through 4 and to kind of think and kind of strategize on what they would use, what properties they would use to deal with fractions. Okay, so if you'll notice, there's a couple problems here that have fractions in them. This one is just adding two fractions together. This one is actually an equation that has fractions in it, and there's multiple different strategies that we can use for these. So what I want you to do now, if you haven't done this yet, if you're working at home, is to pause the video and go through these problems on your own as much as you can. Okay, so you should be coming back from pause now, and you should have worked through these as much as possible. Now maybe you got stuck, and if that's the case, that's okay. We just wanted to get you to think about it and see if you can get most of the way there, and then I can come fill in the gaps for you. Okay, so let's actually start with number 2, and then we'll work our way backwards. This is actually a question we talked about in our previous homework, but let's go down here and talk about number 2. Okay, if we want to add these two fractions together, we're going to have to get common denominators. Okay, they don't have common denominators right now. So we have to kind of see what 120 and 5 both go into. Well, since 120 ends in 0, we know that it's a multiple of 5. In other words, we know 5 goes into 120. We just got to figure out how many times. Okay, it turns out that 5 goes into 120 24 times. So if I multiply 5 by 24, I get 120. But I can't just multiply by 24 on the bottom. I also have to multiply by 24 on the top. Okay? The reason why is that this number that we're multiplying by needs to be a 1. Now 24 over 24 doesn't look like a 1, but we know that 24 divided by 24 is 1. So this is actually a form of 1. And sometimes when I'm doing a problem like this, just to kind of make that clear, I put a giant 1 over that 24 over 24. So really we're taking 2/5 and we're multiplying it by 1. Okay? So we're going to come back and finish this in a minute, but what I wanted to point out is that when you multiply something by 1, you get back what you started with, and that is the identity property of multiplication. All right, so we got that property down. Now that property looks something like this. 1 times A equals A, or A times 1 equals A. So you can see it, you may be a couple different orderings, but that's the idea. Okay, we multiply something by 1, you get back what you started with. Okay, so going back to number 2, and just taking a piece of it right now, not looking at the whole thing, but just looking at a piece of it, if I take something and multiply it by 1, I get back what I started with. So what we're doing is we're taking something, in this case 2/5, and we're multiplying it by 1, only this time my 1 looks a little different. It's 24 over 24. And whatever I get back must be the same as what I started with. Okay? So if we multiply here, 2 times 24, that's 48, and 5 times 24, that's 120. Okay? These don't look exactly the same, but they have to be the same because the identity property of multiplication says so. Right? These things have to match. These things have to match. So they look different, but it actually turns out that these are equivalent fractions. They're the same number. This one's just less simplified than this one. Okay? So that's the property you're using when you get common denominators. So going back to this problem over here, what we have is 127 over 120 plus 48 over 120. Okay? So when we have two fractions and we're adding them together and they have the same denominator, we just keep that common denominator and then we add the tops. 127 plus 48 is going to be, I think that is 175. Okay. And now the last step here, of course, would be to simplify. So now we got to see what goes into both of them. Okay, and it turns out that 5 goes into both of them. So 5 goes into 175. It is, let's see, 20. Let's do the bottom first because we know that one already. 5 goes into 120, 24 times. 5 goes into 175, let's see, 10, 5, 35 times. Okay, I'm just going to double check that really quick to make sure. Yep, 35. Okay, so this is our reduced fraction. Okay, so the point of that, going through all that process, is that to understand that one of the ways that we deal with fractions is using this property. Okay, now on number 3, there's more than one way to solve this this equation here, and I wanted to talk about those different methods. So whatever you did, if you did the same kind of thing as you did in number 2, then the answer to number 4 would be yes, you use the same property. So let's talk about it 2 different ways. Okay, the way that you are probably familiar with, or the way that you might be more inclined to use, is the same method we use up here, the common denominators method. So if you look at this 2-step equation, we'd probably want to get rid of the 2/5. We need to get that on the other side. So we add 2/5 to both sides. Right, cancel them here. Okay, so what we have now is 7 over 10x equals 127 over 120 plus 2 over 5. Okay, now notice that this is the same as this, right? So if you do this problem this way, then you end up having the same sum of these 2 fractions. Now since we already know what that is, we're going to just kind of go ahead and use our work from before. So 7 over 10x equals, now we know this is going to be 35 over 24. Okay. And now we have to kind of go from there. So we have 7 over 10x equals 35 over 24. Okay, and we need to get rid of this 7/10. Okay, so this is 7 over 10 times x. That's one way to think of it, 7 over 10 times x. You can also write this as 7x over 10. Those are equivalent, right? For our purposes here, we can think of it as 7 over 10 times x. Just 7/10 times x. And so we have to divide by 7 over 10 on both sides in order to get rid of it. So now that this 7 over 10 can cancel with this 7 over 10, and we're left with x on the left, which is what we want. Okay, now the right is a little bit tricky, and we have to remember what happens when we divide by fractions. So when we divide by fractions, we've got 35 over 24. What we're going to do is we're going to invert and multiply, or sometimes called keep, change, flip, or copy, dot, flip, or whatever. The difference here is that usually when we're used to doing that keep, change, flip, or copy, dot, flip, we're used to seeing the problem like this, right? This is the division we would see. And then we keep, we change, and we flip, right? Something like that. Well, we don't use this division symbol in algebra. Okay, we use the fraction bars, but the idea is the same. If I have this fraction divided by this fraction, I'm going to keep, okay, instead of a division, I'm going to do a multiply, so that's the change, and then I'm going to flip the bottom fraction. So it's going to look like that, okay? Okay, so now we need to simplify. Okay, what we can do here when we're multiplying fractions is if we see any common multiple or common factors, we can cross cancel. So 7 goes into 35. They have a common factor. 7 goes into 35 5 times, and then 2 goes into both of these. 2 goes into 10 5 times, and 2 goes into 24 12 times. So what's left is a 5 times a 5, which is a 25, and a 12 times a 1. If there's nothing left when we cancel here, that's a 1. So we're going to have this as our final answer. Okay. All right, now if you did it that way, which I'm guessing that most of you did, then we're actually using the same property for number 3, or the same strategy as we use in number 2. And that would be, again, the identity property of multiplication. This idea that we are going to change them to common denominators and then we're gonna combine them. So we don't really see that step here because we did it up here already, right? So if we're using that property, the identity property of multiplication, then we would say yes, we use the same property, okay? The reason why I asked this question though is because there's actually another way to do it, and if you've already seen it, which you probably have from Secondary Math 1, you may have gone that direction, okay? So now I'm gonna show you a different technique, okay? Let's look at number 5, 6, and 7. All right. So for these problems, again, there's multiple ways to do them. If you want to do it the old way, you can do common denominators. If that was the case, then you'd want to multiply this by 3 over 3, and you'd want to multiply this by 2 over 2. And then we'd have 6's across the board, right? That would give us 6's all on the bottom. This, again, is a 1, and this is a 1 over here. Okay, what I want you to notice, though, is that this is actually an equation. Going back to problem number 2, this is not an equation because it doesn't have an equal sign. It's an expression. And so we really only have one choice, and that's to use this identity property. As soon as we have an equation, though, like here or down here, we don't have to use that identity property anymore. We can actually use properties of equality because we have this equal sign. Okay? So instead of using the common denominator strategy, using the identity property, what we're going to do is we're actually going to get rid of the fractions. Okay? So that process is called clearing the fraction. And it uses this property, the multiplication property of equality, instead of this property. Okay? So we are going to, this is the steps. The first thing is you find the lowest common denominator, or what it would be. Okay? You don't have to get common denominators, you just have to figure out what it would be. In this case, we talked about it would be a 6. Instead of turning this into a 6 and turning this into a 6, what we're going to do with that 6 is we're going to multiply both sides by 6. Okay, so that's going to look like this, and it's going to look like this. Okay, now if we multiply both sides by 6, we're using the multiplication property of equality. Okay, in just a second, you're going to actually see how that clears the fraction out, how that makes the fraction go away. So we got 6 over, times 50 over 3 equals, okay, now we're going to have to distribute that 6. So we have 6 times a third. I'm going to write it like this. I'm going to put the negative sign, and then I'm going to have the 6 times this piece, times the 3n over 2. Now you could actually put the negative sign here if you wanted to, but that gets a little bit confusing because then you don't know what to put here. So I like to leave the negative thing in the middle and then just multiply the 6 in that way. So we have 6's across the board once we distribute. Now the interesting thing about this number 6 is that it will cancel a 3 and a 3 and, sorry, I made a mistake. Let me go back. This should be a 6, right? So nothing's changed. This should be a 1/6 over here. And then when we distribute, this should be 1/6. Sorry about that. This 6 that we multiplied should cancel a 3 and a 6 and a 2. Okay, it's the number that 3, 6, and 2 all go into. So let's take a look. 3 goes into 6 2 times, right? So I can cancel out this 3 with a 3 that's inside the 6, and I'm left over with the 2. Okay, so 3 goes into 3 once, 3 goes into 6 twice. Okay, here the 6 is just straight up cancel. There's nothing left over. Okay, and here the 2 goes into the 6 3 times. So the 2 down here cancels with the 2 that's a factor of 6. So what we're left with is we have the 2 left over from the canceling times 50. That's 100. Here we're left over with just 1. And here we're left over with the 3, or the negative 3, times the 3n. So this 3 was left over from canceling. So negative 3 times 3 is going to be negative 9. Okay? Notice now that this is just a two-step equation. Okay? It's something we know how to do really well. And so with just a couple steps, we can clear the fraction, right? We can get rid of the fraction. We don't actually have to get common denominators. If we have an equal sign, if we have an equation, we actually get rid of all of the denominators. That's kind of where we're at. So the rest of our problem here, getting a little cramped on room, but I'm going to come up here. 100 equals 1 minus 9n, okay? And we are going to subtract 1 from both sides, That gives us 99 equals negative 9n. And then we're going to divide both sides by negative 9. Okay, so our final answer here is going to be negative 11, 99 over negative 9, equals 1n, or equals n. Okay, so that is the complete the square, excuse me, that is the clear the fraction strategy, right? We don't get common denominators, we clear the denominators. So what I want you to think about for number 6 is what would be the common denominator. Okay, the common denominator here would be 80. 8 goes into 80, 5 goes into 80, and 80 goes into 80. So what we're going to do here is we're going to multiply everything by 80. Okay? Don't forget to distribute. So I have 80 times 5/8. I have 80 times 9/5 v. And I have 113 over 80 times 80. So now we can start canceling, okay? So I'm going to leave that to you to work on this one. Cancel out the 80s. 8 goes into 80 10 times. 5 goes into 80 16 times. Okay, so you're going to cancel out, you're going to simplify it, and then you're going to solve your two-step equation. Okay? Same thing here. The lowest common denominator here for 12, 2, and 8 would be 24. So my process here is going to be multiply everything by 24. Okay? Don't forget to distribute and then cancel.